Okay, on number 15, it says 15 and 16, identify all given characteristics for the functions shown below. Use your calculator to find any unknown values to 3 decimal places. That's very important, okay? So the first thing you should do is go to your y equals and type in the function. So because we've been doing a lot of statistics, so you might have like plot 1 highlighted and you might have data in there. Make sure, like if plot 1 is highlighted, to go up, press enter, and make sure it's unhighlighted so that it doesn't create any issues. Alright, so let's go ahead and type it in. X to the 5th minus 4x to the 4th plus 2x cubed minus 8x squared minus 15x and then plus 60. It's very important that you check that you typed in the right function, because if you're off just a little bit and I can't figure out how you're off, then it's just wrong. So you need to be careful about that. Okay, so window. If I just press graph, I don't know what the window is right now, but I'm betting it's not going to fit my data, so I'm going to use what's on the graph. So it goes from -8 to +8. And then on the y, it goes from -100. And in fact, that's pretty low, so I'm actually going to go -120. And then up to 100. And then I press graph. Okay. You might notice it's got this weird shape right here. That's because it is a quintic, so it's got more things going on. It can curve a little bit more than a cubic. But anyway, so the first thing we need to do is name it. It is a power of 5, so I'm going to call that a quintic. Now remember, the name has to do with the degree and the number of terms. So it's got 1, 2, 3, 4, 5, 6 terms. So quintic polynomial with 6 terms. Okay. The domain. Now domain is how far left and how far right it goes. Now, I don't know if you remember, but I said every polynomial has a domain of all real numbers, because it's going to keep going down, but as it goes down, it's going to expand to the left, and it's going to keep going up and expanding to the right. So my domain is all real numbers. Now range is, so domain is left and right. Range is up and down. And this function does go all the way down to -infinity and all the way up to +infinity, so it is also all real numbers. Okay, in behavior. Now, guys, it is very important that you use the correct notation, because I will not keep accepting you writing this in a ton of different ways. It's got to be the limit of y as x approaches -infinity equals. Okay? So as x goes to -infinity, y approaches. Well, okay, I can look at the graph, but I can also just figure it out by this. The degree is 5, which is odd. So right off the bat, I've got 2 options. Down up or up down. And because the leading coefficient is positive, I know that it is in general going up, meaning I start with -infinity. So as I go to the left, it goes down to -infinity. And as I go to the right, it goes up to +infinity. And there we go. Okay, there's only one other thing I can answer without graphing, or without calculating on the graph, and that is the y-intercept. The y-intercept is when x equals 0, and I see that it's 60 right there. If x equals 0, all of these terms are gone, and then I get y equals 60. Okay, so now I need to find the x-intercepts. And I notice that there are 3. I've got 1, 2, 3. So I need to find those. Okay, so for x-intercept, I go second, calc, number 2, zeros. So second calc, or 0, I guess. I go to number 2, and I want to find this one first, so I'm going to go a little bit to the left of it, which is down here, and a little bit to the right of it, which is up here. Keep in mind what you're trying to find. I'm trying to find the point right on the x-axis. So that's to the left of it, and that's to the right of it. And these arrows should point where it should create a boundary where your 0 is between them. It says guess, I don't want to, so I go there. Alright. Alright. I need to find the next one. So to the left of it is like right there, and then to the right of it is a little bit below it. Press enter, and I get the positive 1.732. And then I have one more. And that might actually just be 4, so I'm going to look at the table real quick. And yeah, 4 is 0, so that's my third one. Okay. I need, the last parts I need are extrema and intervals of increasing and decreasing. And if I don't have those, if I don't have the extrema, I can't do intervals of increasing and decreasing. Because the function, the arrow points down, but the function is actually increasing. If you graph from left to right, it's increasing. It's increasing until I reach this maximum. So I need to find where the maximum is, because that is when I stop increasing and then I start decreasing until I reach this minimum, after which I turn around and I start increasing. Okay? Now on increasing, decreasing, there's a couple rules. Only X and only parentheses. No brackets, okay? A lot of you use brackets on the homework, but it is only parentheses. So I need to find the extrema. So I can calculate. I need to find the max. Okay, so I've got a max of the y value, 65.100 at x equals negative 0.580. I'd rather you write the 0 than not, because that tells me that you are conscious of the fact that I want 3 decimal places. Okay, so I know that the x value of this maximum is negative 0.580. Now I'm going to find the minimum. So minimum, I need to go to the left of it, which is right around there, and then to the right of it. I mean, like, there's a lot of places to the left and right, but I just go kind of close and call it good. Alright, so I've got a min of negative 88.330 at x equals 3.225. Okay? So 3.225 is that x value. Now, we're talking about the intervals of increasing and decreasing on the x-axis. So when I think about the x-axis, I start way over here at negative infinity. And the function is increasing from negative infinity until this x value, negative 0.580, after which it starts decreasing. And then it starts increasing until I reach, on the x-axis, positive infinity. I don't care where the function is going, it's always negative infinity to positive infinity. So I got some people that are still messing that up, so make sure that you pay attention to that. So I am increasing from negative infinity until negative 0.580, and then I am decreasing from negative 0.580 to 3.225, and then I pick back up at 3.225, and I go to infinity, and I'm increasing. Okay? So there's that one. So let's do one more. Okay, x to the 4th plus 4x cubed minus 5x. And my window. So it goes from negative 6 to 3. And it goes from negative 16 to 10. Alright, the name, the degree is 4, so it is a quartic, and then 3 terms, so trinomial. Quartic trinomial. Okay, domain. Domain is left to right, and it expands to the left and expands to the right, so all real numbers. Range is up and down, and it only goes this low. That is the lowest it goes, so I'll have to figure that out. And in the meantime, I know it goes to up to positive infinity. So I'll figure that out when I figure out that minimum. Okay, in behavior. As I go to the left, and as I go to the right. Okay, this is a even function, which means I've got 2 options. Up, up, or down, down. It's got a positive leading coefficient, so it's up, up. So I can figure it out without looking at the graph, but I mean, I have the graph right in front of me. As I go left, the function goes up. So this is positive infinity. As I go right, the function goes up. So that's also positive infinity. Okay. Again, I know the y-intercept is, well, there's no constant there, right? So if x equals 0 and there's no constant, that means y equals 0. So it actually crosses right here at 0, 0, which means it's also an x-intercept. Okay, I have 4 of them. 1, 2, 3, 4. I'm going to go ahead and go to my table because I think 1 is one of them. And yeah, 1 is 0, so that is another x-intercept. And then I need to find these two. So I'm going to go second calculate 0. Okay, I'm going to find this one. I'm to the left of it, so press enter. To the right of it, press enter, enter, and I get negative 1.38. 1 if you truncate, 2 if you round. Oh, crap. Okay, and then I need to go to the left of it. This one. To the left of this one, which is up there, and then to the right of it. So press enter, and I get negative 3.618. Okay. So the last thing is to do is find the extreme and intervals of increasing and decreasing. So, second calculate, I'm going to find the minimum first. So left, right, and I get that the minimum is negative 12.372 at x equals negative 2.846. And then if I want to find, I'm going to go ahead and, I already know it's a turning point, so I'm going to go ahead and label that. Negative 2.846. Now I'm going to find this maximum. So second calculate max. I'm a little bit to the left, now I'm a little bit to the right. Press enter, and I get that I've got a max of 2.379 at x equals negative 0.744. So the x value is negative 0.774, or 744. And then the last minimum is right here. So second calculate min, and to the left of it, and then to the right of it, and I get a min of negative 2.007, and x equals 0.590. So this x value is 0.590. And remember, intervals of increasing and decreasing, you have, we're going on the x-axis, so over here we've got negative infinity, and over here we've got positive infinity. Even though it's up to positive infinity, I don't really care. We're talking about on the intervals of x. Yeah. So, on this interval, starting from the top, like if you start from the left, the function is decreasing. So I am decreasing from negative infinity to negative 2.846. Now, once I hit the minimum, I turn around and I start increasing. So I am increasing from this value to this value. So from negative 2.846 until negative 0.744. And then once I hit the max, I turn around and I start decreasing. So I'm decreasing from negative 0.744 until 0.590. And then once I hit the minimum, I turn around and I start increasing again. So I am increasing from 0.590 until infinity. And there you go.